A ball moving with a speed of 17 meters per second strikes an identical ball. Okay, strikes an identical ball that is initially at rest. After the collision, the incoming ball has been deviated by 45 degrees from its original direction, and the struck ball moves off at 30 degrees from the original direction as shown in the figure. Calculate the speed of each ball after the collision. Okay, so first of all, we can see this is a two-dimension collision because it got angles, you see, 45 degree, 30 degree. So proving that this is a kind of two-dimension collision. Okay, two-dimension, 2D, two-dimension collision. Now, we have two balls here, and they are identical. Identical ball. These two balls are identical ball. So we can say, what can we say about identical ball? They have the same mass. Yes, they have the same mass. So, okay, we have two balls here. You see, one ball, two ball, ball one, ball two. Maybe we can put this as ball one, and this as ball two. Okay. Okay. Put this as mass one, which is mass m. Mass 2 also have the same mass m. Okay, so we use m to represent both balls because both are identical ball. Identical ball have same mass. Okay, same mass. So yeah, this 17 is the u1. Okay, u1, ball 1, ball 2. Okay, just put it as m1 equal to m. Yeah, m, this m2 is also m. Yeah. Now m2, the ball 2, initially at rest. That means u2 is 0. So we can say, put it here, u2 is 0. Alright, now after the collision, the incoming ball has been deviated. So this is the incoming ball is the moving ball lah. The moving ball, yeah, the incoming ball. This is the mass 1. Yeah, this is the mass 1 deviated by 45 degree. So you see, 45 degrees over here. This is the mass 1. Understand? This is the mass 1. 45 degree below the positive axis, and the other one should be m2 lah. The m2. Yeah. This one is ball 1. This is ball 2. Okay, ball 1, ball 2. And maybe I just change this into green color better. Yeah. The struck ball, which is the mass 2, which is initially at rest, it moved at 30 degree above the positive axis as shown in the figure. Okay, so now calculate the speed of each ball. So the question asks for speed of each ball after the collision. That means you want the final velocity. We want the v1 and also v2. So we want to find their speed. We want to find v1 and also v2 and also the direction, yeah, if possible. Direction we already have. We already have the direction is v1 is 45 degree below positive x. v2 is 30 degree above the positive x. So direction already known. Just that we need to find the speed only. We don't need the direction. We already have the direction. Yeah, we don't need the direction. We already have the direction. We need to find magnitude only for the speed. Okay. Okay, now I want to divide this into two parts. Yeah. First of all, as you can see here, this part is before collision. Yeah, this part is before collision, and after that, this is the this is after collision. The left hand side is before collision, the right hand side is after collision. It's useful to divide this for clearer picture later on, yeah, to select the data. Okay, so as you can see, this one is a two-dimension collision. So what we have to do is we need to do x component and y component, the conservation of momentum. The conservation of momentum. We need to do x and y components separately. We need to do separately. So okay, I divide this into two columns because we need to do separately. So again, I write down the formulas. Yeah, where's the formula? Okay, never mind. Rewrite it again. M1 U1. Okay, conservation of momentum. Yeah, conservation of momentum. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Okay, I already got this. This one also I apply into the y components. Because we will need it for y component also. And then make sure for all the velocity you put the component. So for the x component, the velocity or x component, put it subscript x. Yeah, subscript x for all the velocity. All these are x component velocity. And then for this part, all these velocity are y component velocity. So put that as a y component velocity. Okay. And then remember, for u is before collision. For v is after collision. So same thing goes to the y component. Same thing goes to y components. So right now our job is to write down the information. Okay, write down the information. Okay, one thing is one bonus here is mass 1 and mass 2, ball 1 and ball 2, they are identical. The bonus for these questions, they have the same mass. Okay, so we can write over here, mass 1 is equal to mass 2 equal to m. Equal to m. So what you can say is all of these have the same mass. Understand? All of these have the same mass, m. Okay, m, isn't it? Same thing goes to this part. Yeah, all these have the same mass. So you just substitute m, same m for all the mass. Okay, so okay, so we can cut off. Actually, we can divide by m. This equation, the mass 1 and mass 2, or we can substitute by the same alphabet, m. Okay, so that means we can divide both sides with m, and the m will disappear. We divide by m, so all this become disappear. We can cut off. Understand or not? The left hand side divide by m, the right hand side also divide by m, so the m disappear. So same thing goes to the y component. Left and right hand side, the m just disappear because they have the same m, same mass. So what's left? What's left is just u1x plus u2x, v1x and v2x. And then this one also v1y, u1y, u2y, and then v1y, and then v2y. Okay, so now so look at the x component. First of all, we do x component. Okay, hold on a second, make it longer. Now do the x component. Look at before collision, u1x and u2x, and look at u1x. So u1x, so u1 still u1 is only an x component, so it doesn't have y component. So this 17 is totally this 17 is totally x component, so we can write u1x is and this one is going to the right. Going to the right is positive. So going to the right is positive. So positive 17. Understand? So we can say the u1x is positive 17. We got it. Now how about the u2x? U2 is 0. U2 is 0. So of course no x component, no y component. So this one is 0. U2x is 0. Now how about v1x? V1x, okay, we need to resolve into two components. Yeah, like v1, you have two components. Yeah, this one, and the v2 also have two components. And then don't forget to put the positive negative sign. So like you see, look at v1. The x component is positive because going to the right. But for the y component is downward. You should put a negative sign. Negative. And then v2, it is the x component is to the right, so it's a positive. For y component is upward. Upward is positive also. All those components. Okay. And then you also already have angles. You see, look at the v1. You already have 45 degree. So your 45 degree is over here. This is 45. Okay, 45. And v2 it has 30 degree. So the 30 degrees over here. 30 degree. Okay. Now which one use look at v1. Which one use sine theta? Which one use cos theta? So of course the x component use cosine theta because adjacent to the 45 degree. So that one use cosine. For x component use cosine. For the y component is opposite. Yeah, for y component is opposite, so that one use sine. Okay, all these thing you should know. And then for v2, the x component is adjacent to angle. All right. Okay. For v2, the x component is adjacent to angle, so it's a cosine. Cosine, yeah, cosine. For the y component, it is yeah. All right. For y component, it is opposite to the angle, so it's using sine. Okay. So look again. For v1, the x component is to the right, is positive, and then using cosine because adjacent to angle. For y component, okay, it is downward, so negative. Use negative, and it is opposite to the angle, so use sine. Okay, sine theta. And then for v2, the x component is to the right. To the right is using positive, and then it is adjacent to the angle theta, so using cosine. And for the y component, it is going upward. Upward is positive, and then it is opposite to the angle. That's why you use sine theta. Okay. So we already know everything. The rest is we just put into the equations. So v1. Okay. What is that? Blue color. Now v1x. So where is our v1x? This one. This is our v1x. Okay. This is our v1x. Is positive and cosine. Positive cosine. So it is put as it is a positive v1. Do we have v1? No, we need to find v1 and v2. Okay, so we just put as v1. Okay, positive v1 cosine theta. Cosine what angle? Cosine the 45 degree, 45 degree, cosine 45. Okay, good. Now drag it a little bit over there. Yeah, so yeah, so this thing also drag it a little bit over here. Yeah, now how about v2x? So v2x, v2x is this one. Yeah, this is the v2x. V2x is positive, and then cosine. So just write it down. It is also positive. Yeah, positive. v2x is positive because going to the right. And then v2, we don't have the value. We need to find a v2. So we put as v2 cosine. Cosine what angle? Is it cosine 45? No, 45 degree is only for v1. For v2 is using 30 degree. So cosine 30. Okay, cosine 30. So, okay, we already have one equations here. We have two unknowns. We have v1 and v2. So we need two equations to solve two unknowns. Understand? Here we have two unknowns. So we need another equations which also have v1 and v2. Then we need to do simultaneous equation to find out the v1 and v2. That's the key. Okay, so let's continue to do the y components. I already solved it until here. So we need to find u1 and u1y. First of all, u1y. Is there any y components in u1? Look at this one. Is there any y component in u1? No, there's no y component in u1. It only has x component because this velocity is only horizontal component. It don't have any vertical component. So the u1y is 0. U1y is 0. And then u2y? U2y also, u2 is already 0. It don't have x component and also don't have y component. So u2 is already 0. So u2y of course 0. So this is entirely 0. Understand? Now look at v1y. V1y, okay, after collision, v1y is downward. It's negative, using negative and sine theta. So we need to put a negative sign. Don't you forget the negative. When downward velocity, you need to put the negative sign to show downward direction. Okay, negative v1 sine 45. Okay, so put that as a negative v1 sine, using sine 45 because opposite, yeah, opposite the angle. Okay, and then how about v2y? V2y, look at the v2. V2y, this is the v2y, is using positive value. So it's using positive value because upward is positive. Okay, and then v2 using sine 30, using sine 30. v2 sine 30 degree. Okay. So we have the second equations which also has two unknowns, v1 and v2. So how to do these questions? How to do? What I can see is make it okay. We do by using replacement. We just replace it. Yeah. Okay. First of all, look at these second equations. Try to find v2 in terms of v1. Okay. So this v1 negative v1 sine 45 go to the other side. So what do we get? We get v2 sine 30 equal to, when the partner negative v1 sine 45 go to the other side, become positive. Positive v1 sine 45. So v2 is actually v1 sine 45 divided by sine 30, isn't it? So we already got these equations. Okay. Just now, this is our first equation, and this is our second equation. Do you see that? Now we substitute this into into V2. We substitute into here. We substitute into here to get the V1. Understand? So let's solve it. Yeah, let's solve it. So from the equation 1, we have 17 here, and then we have V1 cosine 45 and plus. Now our V2, we substitute with V1 sine 45 over sine 30. This is V1 sine 45, yeah, sine 45 over sine 30, and then multiply cosine 30. Okay? Are you okay? Yeah, hopefully you're okay. So now from here we can find the V1 because we only left with one unknown. We have V1 here, isn't it? We can find already. We can calculate already. Calculate. So find out V1. Yeah. You just need to okay, never mind. Do step by step. We do step by step. So this is 17 equal to V1. I can actually, this one you can factorize out the V1 because it's a common, you know, it is a common term. So here we have sine 45 over sine 30 cosine 30. Like that. I factorize out the V1. So how to continue? So you just find out the V1. Okay, so how to continue is let's calculate first. Yeah, 17 equal to V1. Yeah, calculate. Okay, so the answer I get is this is 1.9319. Okay, 1.9319. Okay, so the answer and then we divide again. We got the answer is 8.80. That's the magnitude of velocity 1 or speed 1, speed of the ball 1. Okay, we got 8.80. How about V2? So let's substitute. Yeah, let's substitute this one into here. Okay, so from equation 2, we can find out the V2. So this is 8.8. Yeah, 8.80 multiply sine 45 and then over sine 30, and then we calculate again. Yeah, we calculate. We got so I got the answer is V2 is 12.45 meter per second. We got it. We got the V2 already. We got both speed. We got speed for ball 1 and also ball 2. So is it correct? Yeah, is it correct? Yeah. So it is V1 is 8.80, is correct, and then V2 is 12.45. 12.45. Sorry, 12.45. 12.45. That's correct. Okay, so that's it for these questions. Okay, hope you understand. All right, let's move on.